Now that we've learned a lot about how to calculate many different types of derivatives, we're going to turn to what we can do with the derivative. And that's the most interesting part of our whole study of derivatives, is what we can actually use this for. And the very first thing we're going to be looking at is how can we use the derivative to understand more about our original function. And in fact, over the next few lessons, we are going to be looking into developing a few different ways we can use both the first and second derivative in order to help us graph functions much more accurately than we could before. Of course, this has all been made obsolete by Desmos, but if you think about it in a historical sense, this is a really wonderful tool to be able to calculate these things exactly. So, the first thing we're going to look at is we're going to be looking at how we can use the derivative to tell if you look at some function. Let's call this function f. There are periods where f of x is going up, and we call this increasing. And there are periods where f of x is going down, and we call this decreasing. So we have functions that are sometimes increasing and sometimes decreasing. And we can use the derivative. So if you think about the slope of the tangent line, when f is increasing, our tangent line, those slopes are going to be positive, and when f is decreasing, the slopes of our tangent lines are going to be negative. So we can use this information to help us determine when our function is increasing and decreasing. So let f be a continuous function on the closed interval AB and a differentiable function on the open interval AB. Okay, so number one, so if we have a positive derivative, so if f prime of x is greater than 0 for all x on the open interval, then f of x is increasing on AB, on our closed interval. So now there are a lot of different ways f of x can be increasing. So if f prime of x is positive, it could look a lot of different ways. It could go kind of straight up. It could go up and then kind of start to be leveling off. It could be going up and just getting steeper and steeper. Or it can kind of get more steep and less steep and more steep and less steep, as long as it's going continuously up. Okay, so those are all different ways that f prime of x, or a derivative, can be positive. Similarly, if f prime of x is less than 0 or negative for all x on our open interval, where f is defined, then f of x is decreasing on our closed interval AB. And a decreasing function, f prime of x being negative, just means we have a negative tangent line. There's a few different ways that can look too. You could be going down, be kind of going down and getting less down. You could be going down and getting more down. You can be kind of going down and more down and down and more down. As long as you never quite actually level out and you continue going down, that's not quite, we don't really want to be level. We want to keep going down, but maybe in sort of a wiggly sort of way. Then we are decreasing. Okay, as long as we are going from left to right down, we are decreasing. So how would we find where a function is increasing and decreasing? Let's look at an example. So when is f of x equal to x cubed plus 5x squared minus 23x plus 10 increasing? And where is it decreasing? So our answers are going to take the form of intervals. And if, since this function is defined for all real numbers, it's probably going to take the form of infinite integrals. So what we want to be able to do is we want to know, for increasing, we want to know where f prime of x is greater than 0, and for decreasing, we want to know where f prime of x is less than 0. So probably the first thing we should do is find f prime of x. So here we go, f prime of x equals 6x squared plus 10x minus 23. Now let's interpret what we've got. We want to know where this is positive and where this is negative. So if we want to know where it's positive and where it's negative, we have a quadratic. We're going to want to know where it changes from being positive to negative. So we're looking to solve the two equations. 6x squared plus 10x minus 23 is greater than 0. And 6x squared plus 10x minus 23 is less than 0. So the places that are going to form the endpoints of our intervals are going to be the places where it's equal to 0. So we're going to start just by solving for where our derivative equals 0. So we have 6x squared plus 10x minus 23. I'm not sure if I can factor that, so I'm going to plug it into the quadratic formula. We get x equals negative 10 plus or minus the square root of 100 plus 552 divided by 12. And that does not come out particularly evenly, so we will approximate x is approximately equal to 1.3 and negative 3.0. I'm rounding to the nearest tenth. So now we go back to looking at how we're going to solve our equation. So we know where f prime of x, we know where it's equal to 0. Okay, so we know that at negative 3.0 and at 1.3 approximately, f prime of x equals 0. We also want to know now where it's positive and where it's negative. So how can we figure that out? Well, we can pick a point on the interval and plug it in and see if we can work that out. So we have something less than negative 3.0. We can try negative 4. So negative 4 squared is positive, plus 10 times 4 is positive, so we have 16 times 6. That's all going to be much bigger. Negative 4 times 10 is negative 40, so which is bigger, 6 times 16 or negative 63? 6 times 16 is just slightly bigger, so it is going to be positive down here. Pick a point between negative 3.0 and 1.3. Well, let's pick 0. That's a nice easy point. If we plug in 0, we get negative 23, which is negative. And if we look here, we're greater than 1.3. We have, let's pick perhaps 2. So 6 times 4 is 24, plus 20 is 43. 44 minus 23 is going to be positive. So we can pick a point to check. We can look at the product. There are many different ways to go about figuring this out, but we do want to see for each interval, is it going to be positive or negative? You can also think of graphing the parabola. So if you graph the parabola, it's an upward opening parabola because the leading coefficient is 6, and that's why we spent all the time at the beginning of this course figuring out how to solve inequalities with different polynomials and rational functions, and we will be using that a lot in the next few lessons. So now that we know where f prime of x is positive and where it's negative, we can summarize by telling where our function is increasing and where it is decreasing. So f of x is increasing where f prime is positive. So f of x is increasing when x is an element of the open intervals between negative infinity and negative 3.0, union 1.3 comma infinity, and f of x is decreasing when x is in the interval between negative 3.0 and 1.3. And so this will tell us, if you look back at our original function, it is a cubic equation. So our cubic function starts out going up and increasing, then it goes down for a bit, and then it goes back up.